Alright, so example 1. 58,000 meter, we have to change it into kilometer. Okay, so we know that 1 meter, 1 kilometer is equal to 1000 meter, right? And to change from kilometer to meter, we have to times it, and if the other way around, we have to divide it. Okay, so this is my tips lah, okay? So if 58,000 meter, dia suruh change pergi kilometer, what you do is 58,000 you divide with the 10 to the power of 3. 10 to the power of 3 is 1000, but we use in terms of this lah sebab kita sedang belajar prefixes juga kan. Okay, so we divide them in order to get in terms of kilometer. Alright, same thing applies to this 0.0000009 second. Since dia minta dalam micro, which is this one, this one, we know that micro is, again we divide 10 to the power of negative 6, you will then get 9 second, microsecond. Okay, so what I'm trying to say is when it asks you to change from the SI unit into something that will have a prefixes in front of the SI unit, you can divide them. Okay, but when it's already have the prefixes di depan dia, you can times it with the prefixes lah. Okay, P here is prefixes. Alright, okay, right, good. Now is example 2. Bugatti Veyron Super Sport is the world's fastest car. So it has recorded 429 km per hour in Germany on July 10, 2010. So it asks us to convert kilometer per hour here to meter per second. Alright, so 429 kilometer per 1 hour here. Okay, so we have to convert this into a value that has the unit meter per second. Okay, so now what I mentioned earlier, we can apply this rule here. Okay, we can apply that rule. So if 429 kilometer needs to be converted into meter, we have to times it with 10 to the power of 3. Okay, now 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Right? So we have to convert this into seconds. So we know that 1 hour times change to minute, then we have to change to second. Okay? So then we can get the value 429 times 10 to the power of 3 meter over dengan 60 by 60, which is 3600 seconds. Then you will get 119.17 meter per second. Alright, so that's how you convert the unit. Okay, this is very important, okay, because you will be using this concept for all your physics teaching and learning in matriculation. Obviously after matriculation pun apply lah if you apply something that's related to physics or maths, obviously. Alright, so example 3 is the density of a metal mercury is 13.6 gram per cubic centimeter. So what is this density expressed in kilogram per cubic meter? Okay, so 13.6 gram over 1 cubic centimeter. Right? So we know that gram is not the SI unit. The SI unit is kilogram. So we have to change this into kilogram. So we have to do something in order to get kilogram over cubic centimeter. So cubic centimeter pun bukan the SI unit. We have that cubic, which is this one, times 10 to the power of negative 2. Kan? Ay, besar. Wait. Okay, so 10 negative 2. Okay, so if gram to kilogram, if from SI unit into something that have prefixes, we have to divide this with the prefixes. Okay, so kilogram is 10 to the power of 3. Okay, and then cubic centimeter pula, cubic, the centimeter, the centi, which is the 10 negative 2 is being cubic. So being cubic means it is apa ni nama dia? Dia ada, instead of square, dia ada cubic lah. Okay, so 3 di atas sini. Okay, dia 3 kali lah kena darab ni benda. Okay, so you will then get 13,600 kilogram per cubic meter. Okay, boleh faham ka tu ah? Why I put 3 di atas is because sekarang ni dia punya unit is cubic centimeter. It's not just centimeter. If they are just centimeter, you can just directly put 10 negative 2. Okay, but now what we have is cubic, so we have to put 3 lah di sini. Okay, that's why we have to put 10 to negative 2 3. Okay, ingat tu ah. If dia tulis centimeter square, again we still have to do 10 negative 2 and then we square dia. Okay, if cubic lah dia ada number centi tu. Right, okay, repetitive sudah. Okay, so now example 4. Example 4, now we are going into dimensional analysis. Alright, so we have to determine the dimension as well as the SI unit for this derived quantities lah. Let me use white paper. Okay, so we have speed. I'm sorry I don't give you much space. It's for me to limit the amount of pages, but nanti kamu tulis je lah di mana-mana paper or just at the back of the paper. Right, so first one is speed. We know that speed is equal to distance over time, right? Okay, so from here we know that distance is equal to dimension there is equal to L lah, which is length over the time, which is capital T. Okay, then we can then put length, or we can write like this dulu lah, LT negative 1. Okay, so from here we can see that the SI unit, which is M S negative 1. Okay, so this one is simple, so I think you should be able to understand this. Okay, so let's go to B, which is acceleration. Tidak pula ABC, tapi we go to acceleration lah sekarang. Acceleration. Okay, so for acceleration pula, acceleration is equal to ACC equal to distance, velocity over time, right? So velocity pula, dia punya formula is equal to velocity is equal to let me put it here, distance or displacement displacement over time. Okay, so displacement over time is the formula for velocity. Okay, now jangan confuse ha. So over lagi dengan time. Alright, so displacement over time over lagi dengan time means we get displacement over time yang square. Alright, so dari sini baru kita boleh write displacement which is L over the time which is T square, right? Okay, so now we can write L T negative 2, then we get meter second negative 2. So that is the SI unit for acceleration. Okay, so why I do this is because, why do I write velocity over time is because itu memang formula acceleration, right? But then from here, velocity is not a base quantity. We have to change it into something that has a base quantity punya dimension lah. So which is the formula of velocity, which is displacement over time. Okay, so dari sini baru boleh kita cari dia punya dimension yang L, T, bla bla semua tu lah. Okay, alright, next one is force. So force pula, force is equal to, kalau kamu confused, ada tau formula, I've given you the formula here, which is this table. Okay, so you would be able to answer this by understanding and remembering what is the formula for each of this lah. Okay, so force is equal to MA. Okay, so force is equal to M mass times acceleration. Okay, so mass kita itu memang base quantity, so we can just directly write M. Acceleration, we have to change it into let me just write mass again. So we have to convert acceleration into dia punya formula, which is velocity over time. Okay, and then we know that velocity is not a basic quantity, so we have to convert this into something yang memang base quantity. So we know that velocity here is equal to displacement over time. Okay, so displacement over time is displacement over time over lagi dengan time. Okay, so then we can write mass times dengan displacement over time square. Okay, so we have mass, dia punya dimension is M, times dengan displacement which is length over the time which is T square. So what we have here is M L T negative 2. So from here we then know the SI unit to be kilogram meter per second square. Alright, so easy, right? Next one is power. So we have power. Let me just add another paper. Power. Then refer again to the table if you don't know what is the formula. Oh, it's not given. Basically, power punya formula is equal to work over time. Okay, so work pula equal to, ini ada dalam table. So work punya formula pula is equal to force times dengan the distance ataupun not distance, displacement. Okay, so force work is equal to force times dengan the displacement over the time. Okay, next we know that force is again not a, let me just fix this. Force is not a basic quantity, so we have to again do the same thing lah. So force here is mass times acceleration times lagi dengan displacement over dengan the time. Lepas tu sekarang acceleration lagi pula, bukan basic quantities. So mass times lagi dengan acceleration. I'll just skip how you get the acceleration because we've been doing that twice. So I'm just gonna write this one lah, okay? So mass is equal to mass times dengan acceleration, which is displacement over time square times displacement lagi over lagi dengan the time. Okay, alright. So bring this time square pergi bawah, then you will get, wait, did I? Betul lah. Okay, so we have mass times displacement square over cubic time. Time is cube here. Okay, betul? Right? So we then get m l square over t cube. Okay, so this one is m l square t negative di atas because it is per. So you then get kilogram meter square per cubic second. Okay, right. Instead of writing displacement, you can write length. Okay, so I think it's better for us to write length next time. Okay, next is, what was the last one? It is on torque. Right, so did I give you torque punya formula? No. Alright, so torque punya formula is torque is equal to F force times distance. Okay, force times distance. And then again, just now we know what force is. It is the, ini after kita carilah kan, length over time times dengan the distance. Okay, so mass, length, where's the force just now? I'm just gonna write this bit down, okay? This bit. So is it the time yang square? Yeah. Right, so we have m sorry, we have to change this into length to the, okay, so we are using length this time. So we have m l square over t square. Okay, so we get m l square t square, t negative 2 square, sorry. So we get kilogram meter square per second. Okay, per square second. Yeah, per square second lah. Okay, right, so that is the